for the opportunity to speak at the second International Conference of Machine Learning and Applications. I'm Flávio Bernardini from Paulista University, and today I will speak about the analysis of displacement of terrestrial mobile robots in corridor using Paraconsistent Annotated Evidential Logic et al. This work has been developed in conjunction with Jair Minoro Abi, Márcia Terra da Silva, Luiz Antônio de Lima, and Konstantin Miatluk. Companies in the productivity sector are in race for automation and in search for quality and productivity improvements. Investing in research of new technology can improve the transportation production process and the process of mobile monitoring. These researches are increasingly intense throughout the world in the development of mobile terrestrial autonomous robots or AVGs, automated guided vehicles, applied in factories and supply chains. Historically, since Aristotelian thought, logic has contributed to correct thinking, and in the world observations are not limited to false and true states, and often seek to relate reasoning to knowledge. Over time, logic was divided into classical and non-classical, and within the latter, paraconsistent logic occupied a prominent place because it deals with the principles of contradiction, in addition to the basic principles of Aristotle's classical logic. The Paraconsistent Annotated Evidential Logic et al. works with proposition, where P is a proposition in usual sense, mu, favorable evidence, lambda, contrary evidence. Mu and lambda have range between 0 and 1. Thus, according to the equation described and applying the properties of the paraconsistent annotated evidential logic et al., the degree of certainty and degree of uncertainty is calculated. These values will be used as a reference for decision-making in various applications. The table and the lattice show extreme and non-extreme state. We perceive mu equal to 1 and lambda equal to 0 for true state. Mu equal to 0 and lambda equal to 1 for false state. Mu equal to 1 and lambda equal to 1 for inconsistent state. Mu equal to 0 and lambda equal to 0 for paracomplete state. One of the challenges of contemporary robotics is to develop an efficient and safe navigation system applied to autonomous robots. In Brazil, historically, the paraconsistent logic annotated evidential et al. Has been applied since 1999 as a decision-making tool in a navigation system of autonomous robotics. Highlight the AMI prototype, which was a mobile tower with a circular aluminum base equipped with ultrasonic sensor with technology of the time, located in front of the robot to detect possible obstacles. In 2004, M2 was found with a significant reduction in the height of the robot structure and a diameter of 25 centimeters. Following the design of its predecessor, Also used frontal ultrasonic sensors and a programming based on the concepts of paraconsistent, logic, evidential, etal. A free caster can be seen at the front, and the direction of mobile robot was controlled through the difference in rotation of the rear wheel motors. A more advanced version emerged in 2009 with the M3 prototype, whose author's main idea was to improve version 2 to expand the navigation capabilities through a task based on an origin and a destination. This project was conceived based on the predecessor in order to contribute to research in the field of the robotics of autonomous navigation system. According to Miatiluk, the mechatronic system design process contains several phases: plan for development of specifications, project concepts, project details, constructions, service, and retirement. This picture shows the prototype of the project implemented with PIC microcontroller. The difference of this prototype is the placement a servo motor for the control of the robot direction. Side sensors were also placed to correct displacement in factory corridors or logistics centers. The rear sensors are used during maneuvering movements. Another difference is in the use of an LCD to monitor the readings of all sensors, as well as to observe the value of angle pointed out by the servo motor. All these observations will be extremely important in small-scale industrial law plant trials. This table demonstrates the concept terms of true, false, inconsistent, and paracomplete with applications for the robot's decision-making actions determined by extreme state as long as actions determined by intermediate states. Based on the knowledge of the paraconsistent logic and the mechatronic project already in its phase 3, a simulation has been performed with 20 different situations, including static obstacles in front of the robot. Next, a normalization of the readings of frontal sensors for mil and lambda reticulate was made. This normalization process consists of adapting the values obtained for the distance in centimeters and convert them into a range between 0 and 1, which is a concept used on paraconsistent logic. Based on the proposition that the front of the robot is free and applying the properties of the reticulate and logic concepts, the degree of certainty and uncertainty for each of the situations were calculated. As the table shows, the degree of uncertainty could be used for set point for the servo motor, degree of uncertainty, set point, servo motor. The first prototype was implemented with microchips PIC microcontroller. With the datasheet information of the servo motor manufacturers, mainly the electric signal, the C language algorithm was elaborated, whose function is to generate signals for the servo motor precise position. A Tektronix oscilloscope was used to check and adjust the quality signal generated by PIC microcontroller According to the servo motor manufacturers datasheet, the characteristics electrical signals for the stream positions of 0 degree equal 1 millisecond and 108 degree equal 2 milliseconds can be observed on the oscilloscope screen. 1 millisecond, here they adjust, 2 milliseconds, here they adjust. This image illustrates the implementation being checked in oscilloscope for practical operation testing. The platform Arduino, widely disseminated in the world, was used to conduct the tests. The LCD in the simulator shows the value read by the right frontal sensor, and the same line also shows the uncertainty degree. This value shows in the first line. The second line shows the value of the left sensor and degree pointed out by the servo motor. A 0 degree uncertainty is observed in the servo motor point to the middle. 0 degree of uncertainty, servo point to the middle. With imminent obstacle on the right side, the servo motor indicates an approximate value of plus 47, an uncertainty degree of plus 0.49. With imminent obstacle on left side, the servo motor indicates an approximate value minus 47, an uncertainty degree of minus 0.5. With imminent obstacle on both sides, meaning two objects positioned at the same distance simultaneously, the servo motor remains in the middle with 0 degree of uncertainty was calculated. However, the table shows an interesting variation in degree of certainty, which will be used as start point in decision making for speed control algorithm and brake system. Degree of certainty. This work showed the applicability of algorithms developed based on Paraconsistent, Annotated, Evidential logic et al. A detailed design phase in the servo motor of the robot, contributing to the efficiency of the servo motor and assisting the decision-making conduction. In addition, the application of paraconsistent logic keeps the servo motor running within the manufacturer's specifications, which contributes to a longer life cycle. Acknowledgements. This study was financed em parte by the Coordenação de Aperfeiçoamento de Pessoal de Nível Superior Brasil, CAPES. The reference, more reference. Thank you very much.